In this video, I'm going to show you how I turned this shop vac into this amazing high-pressure dust collection system for my workshop. Almost 8 years ago, I built this Cyclone dust collector from an old shop vac, and it still works great today. It's my most used tool in the shop because it's either hooked up to a tool or it's cleaning up after one. The only problem I have with it is it's always in the way. It doesn't actually take up much space because of its small footprint. But I have a small workshop and not a lot of floor space. Usually a shop vac sits here in the middle because it can reach most of the shop and is right next to where I'm working. About 4 years ago, I built this mini Cyclone solely to use it with my overarm dust collector for my table saw. I like how small and compact this one is, and with it mounted up on the wall, it's never in the way. After using this one for many years, I've come to really like it because it's very convenient and is always just a flip of a switch away. I've thought about using this one as my main vacuum instead of the other one, but there's a few problems with that. When I built this one, I plumbed the exhaust directly into my large dust collector so that I wouldn't need a separate filter. This works great because whenever I'm using the overarm, I've got the large dust collector turned on also to collect the dust from under my table saw. If I wanted to use this one for other tools as well, I'd have to run both this and my dust collector at the same time. That's not very convenient, and it's also quite loud. So that brings me to a new set of requirements for my perfect shop vac. It needs to be quiet, it needs to be mounted on the wall and out of the way, and it needs to be able to reach all the corners of the workshop. I'd also like it to be low maintenance, and that means a large filter and an easy to empty dustbin. And so here it is, the Stealth Sweeper. It's mounted on the wall and out of the way. It's got a massive industrial air filter. It turns on remotely, and when it's running, it's only a peaceful 70 decibels, which means I don't even need my earmuffs. And even emptying it is as easy as opening a blast gate. I think this is my best one yet. Let me show you how I built it. I'm going to start by building both the dust collection box as well as the filter box, as they're pretty straightforward. They're really just simple boxes with various ports cut in them, as well as a window on each front for viewing inside. When I was originally designing this dust collector, I wanted these bins to be round. I also wanted them to be see-through so I could see how much dust was in them and how the filter was doing. This meant I either needed a clear bucket or some sort of bucket with a window. Clear buckets were pretty expensive, and there are not very many options. And buckets with windows would be something I would need to make, as nothing really exists on the market. After considering the round options, I thought square bins would be the easier one to make. I considered the airflow that's going on in each side and whether I really needed round bins. On the filter box, the air just really needs access to the filter, and being round doesn't really help with that. On the dust collection bin, there's not really airflow happening inside of that, as most of the airflow is happening in the Cyclone with just dust dropping into the bin below, so I didn't think that bin really needed to be round either. Considering that and how square boxes are relatively easy to make, relatively cheap, and easier to add a window to, that's what I went with. These two stacks will be the boxes here shortly, and I've got the various ports already marked out with the compass. On the dust collection bin, I've got the clean out port here on one of the sides. On the filter box, there's a big hole in the bottom for accessing the filter, and there's a small hole on the side which is for the 2-inch pipe coming from the Cyclone. I'll get these larger holes cut out with the jigsaw and fine-tuned on the sander, and the small hole I actually have a hole saw that's the right size. And look, I got a new drill press table out of the deal. Been needing a new one of these. I bought this hole saw a few years ago when I started using this 2-inch pipe for various dust collection, and it's been great for cutting holes for this piping. It's actually a 3-step process to get a good hole out of one of these hole saws. First, I like to drill a pilot hole all the way through. That allows me to drill from both sides with the hole saw using the center hole as a guide. I also drill out a larger hole near the edge of the outside perimeter, and that's going to allow dust and chips when cutting with the hole saw to escape out that hole, and that will reduce burning. And then I will flip over the part and drill from the other side to make sure I don't get blowout on the back side. For the 2 viewing windows in each box, I'm going to cut those out on the CNC machine because the geometry for where the glass is going to sit is a little bit trickier to cut by hand. To hold this board down on the CNC bed, I've got 2 bolts here in my index holes, and that'll align the board and make sure it's square to the machine. I also drilled 1 hole in the center here that lines up with one of the T-slots, and that's going to hold down the center part of the viewing window when it gets cut out so that it does not get dislodged. And then around the outside, I'll add these 3 hold down clamps, and that'll hold down the perimeter of the part while it's getting machined. Here's a close-up view of that groove and cutout. You can see with the plexiglass here being a piece of wood for now, how this is going to sit in here. The outside lip will keep the plexiglass contained and keep it from moving around. The extra deep groove around the perimeter will be for a bead of sealant to live so that there's good bond and adhesion between the plexiglass and this wood front panel. And here's the dust box window cut exactly the same way. One thing I want to start doing is giving my projects a name and also engraving the date on them. I spend a lot of time designing and making these, so, they kind of deserve it. Plus, it's kind of fun. I'll finish this logo up once I'm done painting later in the project. Since these boxes are going to be under vacuum from the vacuum, I'm a little concerned about the side with the window cut in it collapsing under that pressure. Before I close up the box, I'm going to add these triangular gussets around the inside of the window cutouts, and that'll hopefully stiffen up the cutout to make sure that it can't collapse under the pressure of the vacuum. Despite my best effort to cut all these parts square and assemble carefully, there are some misalignments, and I need both the bottom and the top of the box to be perfectly flush so that when I glue on the top and bottom, they're going to be airtight. And that brings me to this ridiculous setup I have on the table saw. This extra sheet of 1/2-inch plywood is clamped to my fence, and I've squared it to my table. And that makes this one big reference surface that I can use to transfer its flatness to the top and bottom of these boxes. If I only use the height of the fence, any mismatch that's happening on these edges likely would still get transferred to the other side. But this large surface ensures that the whole bottom is on the same plane, and that'll get transferred from one side to the other, and both ends should come out nice and flush. The bottoms of the boxes are cut oversized, and I'll be trimming the rest of it off on the router with a flush trim bit. I find this easier to get a perfect fit than to try to cut the bottom panel exactly to the right size before gluing it on. Doing it that way always ends up with some misalignment. I gave both boxes a quick sanding and rounded over the edges, and now they're looking really good. So it's time to move on to making the tops to these boxes. I'll start with the dust box, as that one's pretty simple and straightforward. It's just a top with a nice round shape on it and a hole cut in it for the cyclone. Since there's a couple of curves, we'll let the CNC handle cutting out this part. I'm not quite ready to glue on the top to this box yet, so for now I'll just hold it in with 4 screws and come back later to seal it up. On my previous 2 dust collectors I made from Shop-Vacs, I used Thien baffles as the separator, mostly because they're easy to make and relatively compact. I know cyclones are very popular in woodworking, and I've never actually tried one, and so on this build, since I'm not so concerned about it being small and compact, since it's going to be mounted on the wall, I'm going to go ahead and try out a cyclone for the separation on this system. You might be thinking, that's a nice box, but seems kind of small. Aren't you going to have to empty that a lot? Well, one of my goals for this system is for it to be easy to empty, which is why I've included the 4-inch port on the side. And the plan there is to be able to hook up my 4-inch dust collection hose right to this port, suck the box empty, and then close the port back up again without even having to take anything off the wall or disconnect any of the piping. So hopefully that works out as good as I think. It's time to finally tackle the Shop-Vac portion of this build and get that motor mounted to the top of this filter box. But first, let's talk about the Shop-Vac. This is the Stelsonic Shop-Vac by DeWalt, and it helps me accomplish one of my goals on this project, to be quiet. There's some impressive engineering going on in this Shop-Vac, making it super quiet, yet really not costing too much more than a normal Shop-Vac. Take a listen. Usually right now I'm running to get my earmuffs because Shop-Vacs are really loud. This is me talking normally, and I don't feel like I need to wear hearing protection. Using a decibel meter, you can see the baseline in my shop is in the 40s. With the Shop-Vac running, it barely cracks 70. As a point of comparison, here's how loud my large dust collector plus my mini cyclone are when they're running together, which is how I use them usually. And here's how loud my original dust collector is made from an old shop vac. They're all really loud, and I'm excited to not have to wear ear protection when I'm vacuuming anymore. I want to keep this power head intact as much as possible, which means I need some sort of an adapter to go from this power head to this box. I've been cutting out some test pieces with OSB on the CNC machine to get this shape right. The first one didn't quite fit the outside shape, and the center hole wasn't aligned properly. So I made some adjustments and cut out a second one, and that one's looking pretty good. I took this file and made a couple more changes and was feeling good enough to cut the final one out of the good plywood. And now everything's lining up good, and I'm ready to attach this one to the vacuum. I pre-drilled a series of holes around the outside of the vacuum head, and now I'm just going to attach the vacuum to the adapter with some pan head screws and washers. Now I could use the shop vac filter that came with this unit and put it in the box and call it good, but you know that's not how I like to do things. I've never really been a fan of these types of filters. They always seemed very cheaply made, and they never seem to seal that great around the vacuum head and often are leaking. And so I found a commercial version of a filter that I think is going to work really good. These are generally used on larger commercial dust collectors, many of them in series, and I think one of these is going to work great as a kind of over-engineered filter for this shop vac. Looking at these filters a little closer, you can see just how much more filter material is on this one than the one that came with the shop vac. This one is significantly thicker, obviously taller, and that means a lot more surface area on this filter, which means I'll hopefully hardly ever have to clean it. It also comes with a very nice and squishy gasket on top, which should be reliable to make a seal against, versus the shop vac one, which is kind of hard and I find more difficult to get a reliable seal on. This, however, does mean I need to make another set of adapter rings to go from this adapter plate to this filter in order to make a good connection and a reliable seal to keep this filter attached to this vacuum head. So back to the CNC machine to make a few more rings. Holding down rings on the CNC is a little tricky because you have to hold down both the inside and the outside of the ring. On my spoil board, I have both homemade T-slots here, as well as buried hex nuts every 2 inches, and I'm going to use both of those to hold down this ring. In the middle here, I've already drilled 2 1/4-inch holes 4 inches apart, which line up with these holes for the buried hex nuts, and that'll hold down the center of the ring. And then to hold down the outside of the ring, I'll use these hold down clamps along the edge. I told you it was hard. Even I thought I had set it up correctly. I don't really need to hold the outside shape. What I need to hold is the finished ring. So what happened here was I cut through the ring came loose, and it chewed up the sides and didn't finish the outside perimeter of the ring to the right size. So unfortunately, I have to start this one over, and I'll clamp it correctly on the next one. I've made many rings in the past using different methods other than the CNC machine. If you'd like to see those ways, check out my other dust collector videos. I've now got 4 new rings to make this adapter. The first one is a stepped ring, and this step is for some foam gasket that's going to make the seal between this adapter plate and the vacuum head, but I will put that on later after the glue has dried and it's been painted. The next ring is just a simple spacer ring to get the height above the existing plastic flange. The next 2 rings are going to work together to provide a way to attach the filter to these adapter rings. The first one here is just a ring, but it's got 2 notches cut out in it, and those notches are going to hold this piece of hardware. This piece of hardware is just simply a coupling nut with a hole drilled through it, and then a threaded rod and 2 nuts going through that hole and locked in place. That'll sit in these notches cut out on the ring. And then the 4th and final ring is the exact same ring with the same notches. We'll capture that threaded rod, and once glued in place, that will provide a secure way to screw the filter down onto these adapter rings. Now that's a filter. I took off the vacuum head to get the adapter plate screwed to the filter box. And with that back together, there's only a couple of parts left. This is the filter access door, and it's yet another circle cut on the CNC machine, but this one's got a step around the outside for a piece of that foam gasket to go, and that'll slide over the same threaded rod that holds the filter on. And when this nut is tightened, it'll compress this ring and that gasket and make this filter door airtight. And lastly, these 3 pieces of plywood are going to make up the wall mount and give me a nice place to secure this whole filter box to the wall. The woodworking portion of this project is finally done, and I'm excited to try them out. I need to glue the windows in place in order to try them, but I want to wait until after they're painted to do that. So off camera, I'll go ahead and get these things finished up, and then we'll be ready for final assembly and to test it out. I finished painting all of the parts my favorite red and black colors, which means I'm finally ready to go ahead and put in the polycarbonate windows on these 2 boxes. The viewing windows are made from 1/4-inch polycarbonate, and they're very stiff but yet easy to cut on the table saw. I just cut these strips down using my crosscut sled, and now I'm ready to glue them in. I'm making sure to use a silicone that's for plastic projects so that I know it will bond to this polycarbonate material. I'm laying just a small bead in that groove that was cut earlier on the CNC machine and making sure it's high enough that it will contact the polycarbonate panel. Instead of making a picture frame and cutting 4 parts out, mitering them together to make this frame, this was just cut out on the CNC machine from 1 piece of plywood, and that was a lot faster than trying to glue up all the joints and make this perfectly square. So now it fits just right, and I can get this screwed on down, and that'll help hold the polycarbonate in from this side. My fun project logo is going on next, and this is just 3D printed letters, and I'm going to super glue them in place. I think this turned out awesome, and I should definitely do this on more of my projects. I'm ready to put the top on this box, and I want it to be removable in case I need to get into the box for any sort of service in the future. That means I need to put a seal or a gasket in between the two parts, and for that I'm using this roll of very thin self-adhesive foam. To help it go around the corners, I'm cutting a small triangle in that corner so that it can go around the bend but still stay mostly one piece without any joint. The dust box got the same exact gasket treatment, and now I'm ready to screw this lid on too. Now with the boxes having their tops on, I can get the hangers installed onto each box. The seal between the vacuum head and this filter box is going to occur on this painted ring. And now that it's painted, it makes a good surface for this self-adhesive EPDM foam that I'll be using for the gasket. That gasket is put at the right depth so that it contacts this ring on the bottom of the vacuum head. And so when I screw this vacuum head down, it's going to compress that gasket and make a nice seal between the vacuum and the rest of the filter box. Before I get the filter installed into the filter box, I want to make a deflector that's going to attach to the side of the filter just inside the intake port. That way, if any debris does get through the cyclone, instead of blasting into the side of the filter media, it'll get deflected by this deflector and go around the filter elsewhere. This is just some scrap sheet metal I've cut out, and I'm trying to get it bent to the same diameter of the filter using this PVC pipe. I drilled a few small holes, and now I can get this installed with some small zip ties. I 3D printed this knob with an extra long stem so that it will reach up into the bottom of this filter and provides a nice way of securing this filter in place without any tools. The last component here for the filter box is the filter door, and I've already gone ahead and applied the foam gasket around the outside of the door here, and it's going to slide over the same threaded rod that holds the filter in place, and one more washer and another 3D printed knob, and that's going to hold this filter door on nice and snug. And once I compress that gasket, that's going to make for a nice airtight seal. The Cyclone came with its own gasket in the box, so I'll get that placed over the hole here, and then I can get this Cyclone bolted in place. This is my favorite part of the project when they're nearly complete and they look absolutely beautiful because I haven't gotten them dirty yet. and I can stand back and just see how far I've come in the last several months since this was just an image of an idea in my head. They look just like my 3D model, and seeing these in real life is very satisfying. I get to know that I solved all the problems that I came across, finding different materials, different components to make this whole thing work, and then using all of the various tools and methods that I've learned over the years to make these things come to life. And seeing them in real life in front of me is just very satisfying. I'm dying to get these things hooked up and on the wall so I can test it out. And in order to do that, I've got a few more 3D printed parts to make that happen. I'm going to be using 2-inch ABS black pipe to plumb this together, and the first 3D printed part here is a flange that fits that 2-inch pipe perfectly, and I've cut out this flat EPDM gasket with adhesive on one side, and that'll go on the back side of the flange, and when I screw that down it'll make a nice connection between the ABS pipe and the filter box. The clean out on the side of the dust box is sized for 4-inch PVC pipe, and so I've got another 3D printed flange here that fits the 4-inch pipe, and it's already got the same EPDM self-adhesive gasket on the back, and I'll get this screwed on to the dust box. On top of the Cyclone, I've got 2 more 3D printed couplers, and this one fits snugly in the top of the Cyclone and will adapt to the 2-inch ABS pipe fittings. And this one here also fits nicely in the inlet port and will also adapt to the 2-inch ABS pipe. To hang these on the wall, I'm going to be using French cleats, and I've already got 2 of them mounted on the boxes, and I've got a plate mounted up on the wall, and so I'm ready to go ahead and hang the first one. Just don't drop it. Nice. Solid. This clean out port is going to get plumbed into my main dust collection line, and I've already gone ahead and added a Y and elbow and some 3D printed parts for a blast gate and these 3D printed gasket clamps. If you're interested in how I've made these, I've got other videos that I'll be sure to link down below. To connect these ports together, I'm going to use some 4-inch flex hose, and I've really been getting tired of using hose clamps on this stuff because it kind of really sucks. And so I've designed and 3D printed this spiral hose adapter, and it just threads right on to the spiral of the flex hose, and when it's threaded on all the way, it doesn't even need a pipe clamp because it's essentially self-sealing. I'm going to put one of those on each end of this flex hose, and then the blast gate can then get connected to the dust box. This idea to add a cleanout port right to the dust box actually came from a comment on my last dust collector build video. And I thought it was a good idea, except for one flaw. And that's that these blast gates tend to leak air just a little bit. They're not perfectly airtight, and I would think a small leak on the Cyclone dust box would probably reduce the performance of the Cyclone. And so to solve that, this cleanout port actually has one trick up its sleeve. When I designed this port, I added in a couple of notches here that are going to accept this cross member with this nut inside of it. And then I've got this 3D printed lid with more gasket material around the outside and this star knob. And that will thread right into the nut. And once tightened down, that gasket material will provide a nice airtight seal on this cleanout port. And I can even go ahead and store the flex hose right over top of it in the meantime. I'm so close to testing this out. I only need a hose and to plug it in, and then we can see how it works. I'm going to use this large shop vac hose to connect to the Cyclone, and I'll just zip tie it to my existing piping to hold it up there for now. Having this hose here will allow me to hook up my overarm dust collector for my table saw super easily and have the hose out of the way. And this looks really good. Also, to clean the rest of the shop and the surrounding tools, I've got my regular shop vac hose and the floor clean tool, and I can plug that in the same way. The last thing to do is to turn it on, but since the switch is up by the ceiling and I can't reach it, I went ahead and picked up one of these remote outlets off of eBay, presumably some older woodworker who didn't want theirs anymore, and now I can turn it on remotely. I got this pile of dust from under the table saw, and it'll make a perfect first test. Here we go. Nice. I went ahead and cleaned out a bunch more dust from under the table saw, and now you can see my dustbin is partially full, as you can see through the window. And now we can test out the clean out port and see how that works. I let this run for about a minute, and while it didn't clear out all of the dust, it did a good enough job. My thought on how to use this is to let the dustbin get about half full, then do this clean out function with this port, and let it clean out as much as it can. Since it's relatively fast and pretty clean to do this, I won't mind doing it. And that's a win. You can tell on the window that a little bit of dust got through the Cyclone, and I think that's to be expected. It's not going to be 100% perfect. After sucking up all of that dust, let's see what the inside of the door looks like. You can see that it's mostly super fine dust, and not any big particles made it through. So I think it did a great job. I always think projects like this are a triple win. I get a cool new tool to use, I learned a lot along the way, and hopefully you got some entertainment out of this video as well. Thanks for watching, and I'll see you in the next project.